right?
Yeah, we discussed that, and you asked us to set up Java and also try to understand what about each daemon, and yeah,
That's one thing.
that's what we discussed.
Yeah. So it's not to evaluate any of you here, friends, but I would like to hear from your end. What do you mean by an environment variable?
Which can be used across the system, a variable which can be used across the system.
A variable which can be used across the system. Okay. Environment variable. That's fine. Anything better than that?
So, variable that can be accessed from any path in the system.
Variable that can be accessed from any path.
Irrespective of the path. Yeah.
Okay, irrespective of the path. Okay. So, anything better than that?
A variable that can be used by any process running on the system.
This is more convincing. More convincing. I appreciate. More convincing. So, environment variable. I mean, why I'm asking you this one? These are certain basics. Maybe you may feel why Srinivas is going here and there. We may not be able to understand that as of now, but these are certain things that are essential. Environment variable. Though we are not interested to look at the definition part of that environment variable, let me record this one. Sunil, are you recording this from your end?
Yes, Srinivas, I am also.
Oh, you're recording that one. Okay. Fine, that's fine. So, environment variable is echo dollar path. So you got some value here. I mean, what we got the answer last. I think it is Arun who mentioned it. The variable that is being accessible to all the process running inside the operating system. Yes, to the best extent. So we know we have something called local variable, local to that particular context, maybe within the program. You define any variable within the function. That variable is accessible only within that function. You declare any variable, maybe int add int a comma int b. I say here int result equals to a plus b, return. I say here this result is a local variable. Within this function, add only this result is accessible. Once you go out of add function, result is not accessible, result is not visible basically. Suppose I define a variable called void main this result is accessible throughout the main. But still it is confined to the main only. I declare a variable here that is accessible throughout. But if you observe closely, where this is called a global variable. But if you observe closely, this is confined only to this process. Only this process can make use of that result variable. Here, the main function is able to use. Here, only add function is able to use. I'm showing you the different scopes. Now, inside operating system, we have different process running. If all the process need to share certain things common, then what is the place you declare those? Is a question. That is the reason why engineers has developed this concept called environment variables. Every process that gets loaded inside the operating system receives a copy of the environment variables. So that they are accessible to every process. Please observe this one, friends. Every process that gets loaded inside the operating system receives a copy of these variables. Which variables? Environment variables stored at the environment. Environment, I mean OS. Variables stored at add function level, variables stored at main level, variables stored at application level, variables stored at operating system level. Variable stored at operating system level is what I call it to be environment variable. So every process that gets loaded inside the operating system receives a copy of the environment variable, so that these variables, this is one way that process communicate with each other. This is one way the communication happens among the process. This is one way. I don't say that this is the only way. This is one way. Example to the environment variables: path, class path, Java underscore home, Hadoop underscore home. As these are related to our context, we are compelled to discuss all these things. Now, can any of you tell me what is the importance of the path and environment variable, friends? Can any of you tell me what is the importance of path environment variable? We have understood what is an environment variable, but can you tell me what is the importance of path environment variable?
It will have all the library file information. I mean, in the path only we'll be mentioning where all our libraries are, required libraries are there.
Not libraries, our executables are.
Yeah, execute.
So where all our executables are located, which you want to access. If you want to access, usually what happens, you want to access any executable, you should go its path. You should go its path. From there only you can access it. Say for example, you want to access your java.exe or javac.exe. You know very well Java C and Java are called they're technically called as the Java compiler and Java interpreter. Java C. If Java C if it needs to be accessible to you, you have two ways. One, you should go to the path where Java C is available. That is usually inside your JDK bin. JDK bin, your Java C is available. You need to go to that path, JDK bin path. From there, Java C is accessible. But you want Java C to be accessible from anywhere within your operating system or by any process running inside the operating system, because there are many applications when they run, they need to access these Java executables or Java binaries. So if you keep that as part of your path environment variable, I mean your JDK bin, then all the binaries inside your JDK are accessible to you. One classical example for that is Java C. Of course, friends, if you have any concern, please let me know now itself. If any of you are feeling different, hey Srinivas, what is this environment variable and all, what is this path and all? Even after discussing all these things, still you feel that something is missing or you are not able to understand, please let me know. People who are very clear with this one, please bear with me, because this is essential. As an admin, you need to set up things in Hadoop space. You should know what these are and what role these concepts contribute. So path environment variable helps in showing the path of the executables to your programs or process running inside. Example is Java C, Java and all these things. Class path is something like, I can say this one as, shows the path of the executables. That is the reason why when we install any software, if binaries are expected to be accessible, then we set that as part of path environment variable, usually till bin of installed software. So that what is advantage? Whatever the software that you have installed, that is going to be accessible to, I mean, its binaries are going to be accessible. Usually, that is where I'm giving you the classical example. If Java has been installed, you want Java C, I mean Java compiler, Java P, Java profiler, JDB, Java debugger, like this. If tools of JDK needs to be accessible from everywhere, then till JDK bin we need to set as part of the path environment variable. Can any of you tell me what is class path environment variable, friends? Class path environment variable.
That's the path where the classes used by the Java code are present.
Very. So class path is the one which shows the path of the dot class files. Like how path environment variable is going to show the path of the executables. Same like class path is going to show the path of the dot class files. You know very well what is a dot class file. Your .java file when being compiled, you get a dot class file that is required for our execution. So where your dot class files are present, or where the libraries, Java libraries are present, I mean your ZAR files are present, so those details will be stored as part of your class path environment variable. Same like Java home. Hadoop home. What do you understand from these environment variables, friends? Java home and Hadoop home. What do you
Java
understand
home
from
is
these? Yeah.
Java home is nothing but where the actual Java is installed on your machine.
Ah, very good. Hadoop home.
I feel it's the same where the Hadoop file system
Exactly.
are.
Exactly. Where your Hadoop, that is where I mentioned, friends. I don't know whether you are with me on this or not. I clearly mentioned it when I was discussing about Hadoop. Hadoop dot apache.org. If you take that, hadoop.apache.org. Apache Hadoop software library is a framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. So which is a clear indication that your Apache Hadoop is a software library. If you set up Hadoop, then the libraries needs to be accessible, because you know very well Hadoop core. When I use the term called Hadoop, I implicitly mean by core, Hadoop core, not other things, Hadoop core. On the top of core, there are other components being set up. What are being set up? Your pig, hive, scoop, all these things are being set up. Those components requires where Hadoop is available. That is the reason why we need to have your, what is that needed? What is that needed, friends?
Hadoop
Hadoop
home.
home is needed, because Hadoop home is going to guide where your Hadoop is being set up. Hadoop, I mean core, both your HDFS and MapReduce. So where your Hadoop home, where your Hadoop is being set up, that is what we call it to be Hadoop home, which is essential for us to set up your components as part of the ecosystem. Many times you might have, I don't know whether you have gone through this document or not. I requested you to go through this document. So somewhere I'm just showing you. Hadoop underscore. Yeah. Look at this one, friends. It is also traditional to configure Hadoop home in the system, in the system-wide shell environment configuration. For example, a simple script inside etc profile D. You see here, Hadoop underscore home. The value is path where your Hadoop is been set up, and we export that one so that your Hadoop home is available to every component as part of the ecosystem. Same like other environment variables. Hadoop PID underscore DIR, the directory where the daemon process ID files are stored. Hadoop heap size max. Like this, you can define any number of variables which are needed for your process to run properly. See, I know very well, if you know all these things, you become more productive and you start getting more questions. I face more challenges. No problem. Let it be, no problem. So I think you are seeing here, environment variable for name node, data node, secondary name node. So usually most of these are being set when the library is being set up or when the environment is being set up. So we need not worry much for that. So most of these variables are being implicitly set, but I am just trying to make you to understand what is this environment variable. Is this clear, friends, what I have described, or any questions from your end? Yeah, Nee, Vijay, Dr. Veera, Dasari. Please unmute yourself, friends. See, I want to get the understanding from your end till we finish the first few sessions so that I understand and evaluate your abilities and your skill set so that the next journey is going to be more smooth and not boring.
Yeah, I'm able to
Some
follow
of you
you.
have already taken my sessions, that's fine. But people who hasn't taken my sessions before, I want them to be more active during the session so that I understand. Yes, you are following them now. Yeah, please go ahead.
No, I don't have any questions on this.
Yeah, I'm able to
So
follow you.
clear?
Thank you.
Yeah, wonderful. So if you have any questions, please don't hesitate, friends. These certain basics are very, very important for us, right? So as been mentioned by me in the last discussion,
Hello?
now we have, yeah, Nee.
No, it's me, Marsh. So from the environmental variable to all these path, class path, Java home, Hadoop home, is it a part of it or is just the example, this path, class path, Java home,
Now
Hadoop home?
part of it only. We noticed here, right? We noticed here, I think you noticed, you saw those things as part of your Hadoop even, Hadoop underscore home. Some part during your setup process, you also see Java underscore home also needed. Java
Okay,
underscore home also needed. These
so
are all required.
these are the like
Not
example of the environment variable?
exactly. All these are the examples of environment variables.
Okay.
And you also see here, see, these are definite environment variables which you will be coming across. Path, class path and all. These are definite environment variables which always exist. But when you specifically come to Hadoop, along with these environment variables, we also come across variables like this. See here, all these are environment variables.
So you basically, whenever we need a path or anything that we need to be accessible, everything you call it to environment variable, but everything is different things, like Java underscore home, Hadoop underscore home. It's different things, but everything is called under environmental variable. Am I
Yeah,
making?
you want a variable to be accessed only in a process defined in that process. Observe here very closely. You want a variable, that is the reason why I have taken this example. I don't know how you received it. You want result to be available only within add function, declare like this. After add function is over, its scope is over, add is not visible. You got it?
Yes.
But you want a variable accessible throughout the main. You declare here that is accessible throughout the main. Because you may be calling one function here, add 10, 20 you pass. You are calling the function here, friends. Subtract 25, 50. So like this, you may be calling different functions. Let all the functions will be using this result. Result is accessible to all those functions because that is present inside the main. Anything declared at the main level is accessible to all the process that your main is going to generate, or where the process has got the access to the main. That is different. If the entire process need to use, declare at the global level. But if multiple process within the operating system need to use, then comes is your environment variable. So local variable, local to main variable, global to main variable, and global to all the process running inside the operating system. That is where we call it as environment variable, variable declared at the environment level, which is accessible to every operating system every time. every process running inside the operating system. So environment variable is a variable at the environment which is passed to or whose copy is given to every process that gets stored inside the operating system. That is the reason why they have the access. So whatever is needed, it is being used. Other things, if needed, we'll use, otherwise we ignore them. But a copy of the environment variable is going to be given to every process that runs inside the OS.
Srinivas, one
You
question.
should notice, yeah.
So when you're showing the environmental variables for Hadoop, I saw that the environmental file is under etc/Hadoop. So for Hadoop, is it a separate folder? Because I thought all the environmental variables on Linux or Unix system will be under etc/profile.
No. Environment variables will not be there. But thing is, they are being exported through that mechanism. They are being exported because when the operating system starts, if you want certain environment variables to be available, someone should export them, right? Otherwise, it will not be. That is the reason why, not only declaring the variable, an environment variable, we also need to export them so that they are fixed at the environment level and they are accessible to all the other process running inside. So you look at here, I'm not only setting that one. After a Hadoop form has been set up, I should also export that. That is not been exported, then it is not. Where you are setting that one, probably from the command line or from a file or something, environment file, something like that. Then if I don't export them, they are not accessible or visible. So that we'll be doing through those files, profile files and all. Using those files, we'll be doing export activity after value is being set. You got my point, Sunil?
Yes, Srinivas.
But they are not going to stay there. They are not going to stay there. They stay always at the operating system level in the form of export command only. Okay. But how we do that one automatically when the operating system starts, we keep these things as part of some file and make that file to be executed. So automatically all these environment variables are being made available at the OS level. Right?
Got it.
Wonderful. Dr. Veera Dasari, Dr. Dasari, are you available? Okay, good. I'm not watching the messages. Now I saw. Yeah, that's good. You wish you can unmute yourself. I think if these things are pretty clear to you, maybe it's slightly boring, but we need to have the understanding as everyone needs to be on the same common platform to discuss certain aspects. Yeah. So to set up either your pseudo cluster or a standalone setup or even a fully distributed mode, these are definitely required. These environment variables. Installation path, that is the reason why I discussed these things. Otherwise, these are not required to us. Installing Hadoop cluster typically involves unpacking the software on all the machines in the cluster or installing it via a packaging system as appropriate for your operating system. Don't worry, we talk about these things. It is important to divide up the hardware into functions. Typically, one machine in the cluster is designated as a name node and the other machine as a resource manager exclusively. These are called the masters. Of course, we discussed in the place of resource manager, we discussed about job tracker in the last session. Let us continue the same till a few sessions, because the resource manager node manager, all these things comes under the concept of YAN, yet another resource negotiator, which is advanced to your Hadoop core. So initially it was Hadoop, later it was Hadoop 2, and where a lot of changes happened, where other distributed computing frameworks also can be set up on the same Hadoop cluster, so that they can make use of the data that is being present on your HDFS. So for the sake of running your or processing your data, we use MapReduce. For that sake, we have one cluster. I process the data in a different style, written in a different language. I need to have a separate cluster, though you may be able to set up, but making the data available becomes a big headache. That is the reason why I want HDFS to be the central or the soul to store your data, and on the top, let you develop any computing framework so which is capable of executing and processing this data and needs to take care of that. So that is where here these are the masters. I think you need to have some document. To show you a diagram. Yes. Look at this diagram. Please look at this diagram, friends. I'm making it more accessible to you. Yeah. I want this diagram to be printed in your mind. Because my next thing is, see, environment variable, I said, software, Apache Hadoop is a software library, I said. When we are setting up this one, we need to set some environment variables we came across. Now, we have the 5 daemons: name node, secondary name node, and then we have data node, then we have job tracker and the task tracker. That's all the 5 daemons we have. And these daemons, how we make these daemons available, how we make these daemons to run, based on that only we are getting this classification. What classification? We have a, in how many modes your Hadoop is available? Hadoop is in one of the following forms. What is that? Standalone mode. What is the next thing? And what is the last thing?
Fully.
Yes. So, even we start with standalone mode, what I mentioned here, the diagram, these daemons, there is some relation that exists between the daemons and the modes that we are about to discuss. We talk about it, don't worry. But I want this diagram to be printed in your mind. What is data replication on multiple nodes and how that is happening. So I want you to understand this. The terminology, this is the terminology basically. Understanding is quite simple. Something which is simple to understand is hard to implement. So you look at this one. If a client wants to get the block information, or the client needs to submit the job, But ultimately, data reading and data writing is happening directly between the client and the actual node. Please watch this diagram closely, friends, and engrave this diagram in your mind. You have any difficulty understanding anything here, please let me know. We will discuss on it. But I want you to quickly go through this diagram so that we can have a more meaningful discussion on it. Take a minute or two, friends, to look into this diagram closely.
So Srini, so if I'm running a MapReduce job on the client actually sends the job to the name node for tracking. But if the job is actually reading data, it comes back to the client?
No, I didn't
Is
get
that how
your
it
question.
works?
No, I didn't get
If
your
I
question.
have a MapReduce, if I have a MapReduce Java job,
Okay.
I'm running it on the client.
Yeah.
Okay, so that job is actually run on the name node, correct?
Yeah. No. It will not. No, it will not run on the name node.
So it runs on the client. Okay.
It will be submitted to job tracker, right?
Yes.
So the job tracker is on the name node.
No. It is been shown here. Let me also show you that. Usually, these are expected to be, whatever I'm showing you here, these are expected to be set up each on a separate machine. This is only for your understanding purpose, we did that. But usually, in the real environment, what happens? They will not be done like this. See, name node on a separate, let me, 1 second. Give me a minute. See, name node is one daemon which is expected to run on an individual high configured machine. Job tracker is one daemon which is expected to be running on a separate machine with the high configuration again. Secondary name node also on an independent node, different node with high configuration again. But the slave node will have both data node and the task tracker running together, both. I don't know whether you notice this or not. Maybe this might have misled you, but I'm sorry. Name node, job tracker and task tracker, name node, job tracker and your secondary name node, they exist on 3 independent high configured machines, which are considered to be the masters for your ecosystem. Of course, you'll be having other components as you keep growing. But these are the 3 daemons that are going to run and give the expected service. What are those? Name node and the backup to the name node called secondary name node. And the third one is the data node as part of your storage. And next, fourth, that is your job tracker, and the fifth one is a task tracker. Both data node and task tracker exist on the same node. They don't need independent. They can be on the same node. But your name node and your job tracker and your task node is on a different machine, but on a pseudo cluster, we will keep all in one as one single bunch. honestly speaking, your resources needs to be independent. Yeah.
So Srini, my doubt was, I have a cluster, right? So the cluster has name node and it has say 32 data nodes. So the cluster is separate. Now I want to, from my machine, I want to run a MapReduce job, okay, accessing that actually accesses data on that particular cluster. So then I'm the client. So when I run the MapReduce job, the job is actually sent to the job tracker on the name node for all scheduling and running purposes, correct? But where does the job actually run? Does it run on the name node or does it run on my process?
That's a classical question. Though it is not related to the administration part, but as we need to know that one. See, your job runs on every node where the data for the given data set is present, so that your job is going to process the data locally then and there itself. I'll give you an example like this. Give me a minute. Say for example, you want to process a file called foo, okay, which is present on /tmp/foo.txt assume. This file you want to process. What usually we do is, we develop a job and submit the job to the job tracker. Job tracker internally communicates with the name node. Observe here. That is why name node is technically called as POF. I don't know whether you've gone through this document anytime or not.
Single point of failure.
Yes. You are right. Single point of failure is what I call it to be POF. If name node is down, everything is down here, friends. Entire cluster becomes inaccessible. It is not at all accessible if the name node is down. But if job tracker is down, no problem. We can make it up. Cluster will be running. You can make your job tracker to be up and running. But cluster is still accessible. If a name node is down, cluster will not be accessible. What is the setback? Why I am saying cluster is not accessible? Your name node knows where your data is present on the cluster. Now, I want my job to process a file called foo.txt. I submit the job to the job tracker saying, process the file foo.txt and give me this output. Yes, it will do that. But when the job is being submitted to the job tracker, how the job tracker knows that these are the 10 blocks that I need to process for this given file? Because the job tracker internally communicates with the name node asking where the blocks for the given the job tracker internally asks the name node where the blocks for the given file are present on the cluster. Name node replies, oh, you want to process a file called foo. This has got 3 blocks. Okay, and are present on node 1, node 5 and node 6. Then immediately what the job tracker will do, receive that jar file, and that jar file is sent to only these 3 nodes, because in the cluster there may be 100 nodes. I will not be sending my job to all the 100 nodes. I will be sending my job only to those 3 nodes. Node 1, node 5 and node 6. Did you got this point, Arun?
Yeah, I got it. I mean, the reason I got confused was in your diagram, there was a data read and data write going from client to the data node directly. That's where I got confused.
Yeah, you are absolutely right. That is what the communication happens. But how? Only through the name node. Because how the client knows that I need to write the data to this data node, or I need to read the data from this data node. How the client knows that?
Okay, got it. So it has to go through the name node.
Absolutely. Let it be your job execution or let it be data storage, but ultimately it should go through the name node. Because name node is the one which tracks all the details about your data storage. So what is going to happen is when the client submits the job to the job tracker to run that one, of course we are submitting to the job tracker only, but how job tracker will decide that this jar file needs to be sent only to these 3 nodes? Imagine your cluster is a 50 node cluster. Imagine your cluster is a 50 node cluster. How come the job tracker will know that out of these 50 nodes, only these 3 nodes where the required data is present? How come? At the time of storage itself, it has kept all these details. So, when I submit the job to the job tracker internally communicates the name node asking for this given file where the blocks are being present. To those nodes, your jar file is being submitted so that I can achieve data locality. Where data is present, there only I do the processing. I will not be pulling the data to one common place and process it. That makes no sense when you're working with Hadoop.
Srinivas, Vijay, can you hear me?
Yeah, please.
Actually, I've been typing something on the chat window. Can you please have a look?
No, I didn't get your point. Can you be a bit loud, please?
Okay, I typed something in the chat window because my audio controls weren't working for the last 15 minutes. So then I just dropped the call and then rejoined.
Oh, Vijay, okay.
Because
go overview the diagram. Okay. Fine. I didn't notice Vijay, sorry. Because I minimized this one, I didn't notice that.
Because to me, last
so, I mean, we'll talk about it. We'll definitely talk about
Latin and Greek, actually.
Oh, okay.
Yeah.
So, look at this diagram closely. As been mentioned by me in the last discussion about 5 daemons. I mean, your entire Hadoop runs on the master-slave architecture. You know very well that when I use the term called Hadoop, I implicitly mean by core, and it has got 2 things, that is HDFS and MapReduce. HDFS and MapReduce. HDFS is basically to store the data, and MapReduce is basically to process the data. So here also we have a master slave, and here also we have a master slave. And what is a master here? The master in HDFS is name node, a backup to the name node called secondary name node, and the slaves are nothing but data node. In the MapReduce section, we have job tracker and task tracker. So, name node and secondary name node exists on a high configured machines. Name node and secondary name node exists or been set up on a high configured machines independently. Whereas data node is being set up on a commodity hardware within the cluster. On the same machine, your task tracker also been set up by your environment. both data node and task tracker exists on the same node. Why? Because I want to achieve the data locality feature, data locality feature. You got the point?
Srinivas, one question.
Yeah, please.
So can we say one cluster will have a name node, job tracker node, and multiple data nodes with task tracker nodes? So each cluster will have one name node, one job tracker, and multiple data node plus task tracker. So can we say that?
Absolutely.
Okay.
Absolutely. No second thought. You are absolutely right. That is where you see this diagram here. Master, I mean, usually that is where they have mentioned it as an asterisk here. See, masters are being set up individually on separate nodes. They are not being set up on the same node. Of course, for POCs and all, that's fine, but that's not in. See here, server node hardware recommendations and hardware for slave node separate we have. But typically when you're doing some POC and all, never mind, we do everything. That is all. But there is a separate this thing available here. You can see that. We talk about the content. Yeah.
Srinivas, this is Vijay. I'm going to ask some questions in a term that I understand, so that you can help me. So let's assume that you have three machines, okay, three different servers, and I have to put them in a cluster, and I have to make sure they are accessible. So, and this is my requirement where if the Hadoop server software, whatever that is running in one server, because all these three are in a cluster now, if Hadoop software running in one machine goes down, I should still be able to access this environment in the maybe in any one of these other two servers, so that I know, because I need to log in, right, to see which one has gone down and which are all running. So I have to have two nodes, which you can call them as master nodes, and the third one can be a slave node. I don't care, because that's only to run my process. If this is my requirement, where I need to have two nodes, if one goes down, the other one will be up and running, so that I can still log into the machine, log into the software, and see what's going on. And then, if required, I can actually bring up the node that went down. And the slave node is only to run the processing. In this case, how will you define? This is the requirement. How will you define? Like which one? How will you define in Hadoop, or how will you implement this requirement using Hadoop?
On a that is where, as I mentioned here, standalone. Let me put this way, then you'll be able to understand. One machine and one JVM. JVM, I know, Java Virtual Machine, to run MapReduce job. Okay. One machine, 5 JVMs, one each to run name node, there will be 5 daemons running on the same machine. But when you come to a fully distributed mode, we have at least 3 machines. 3 will not be good again, because replication is also needed. 5 machines minimum, 5 machines, 1 to name node and 1 to secondary name node, maybe 1 to job tracker, and we have a task tracker plus a data node plus Okay. Same like 2 data node plus task tracker, 3 data node plus task tracker. So I say not even 5, 6 are definitely needed. So to see the replication, basic replication factor of 3. Same block is being made available at 2 other places inside the same network. I say 6 machines are minimum needed. Why? Your name node should run, your secondary name node should run independently, and your job tracker, your task tracker and data node runs on the same. But when it comes to the replication, each block should be made available at 2 other places on the same node, on the same cluster. Then keeping that thing in the mind, I need to have at least 3 slaves. Now come back to this diagram.
But is that 6 machines is mandatory?
No, not mandatory, but what I do is, again, that is what, when I am doing POCs and all, what I do is, I also going to make use of my name node, secondary name node and job trackers as the slaves, masters and slaves.
Okay.
That is where you may be getting confused slightly, because these are the
Yes,
daemons. I set up these daemons to run on the same nodes. Then with 3 machines also we can set up.
But my requirement is very simple, this is what my requirement is, Srini. They have given me 3 machines. They have said I have to set up a high availability and load balancing. These are the requirements. They have given me, they said, okay, you have 3 machines. Now set up a cluster where we need to have high availability, which means if one node goes down, the other becomes active and that controls, so that the process doesn't fail. Third thing, we have to have a load balancing feature, which means all the 3 nodes are available and the load data processing gets distributed. If I have to implement this requirement, how should I configure my Hadoop so that which one will become a name node, which one will become a SN, where will be the job tracker? Can you just explain me that?
Yeah. Got your point. See, in that case, what I'm saying, 3 nodes you have, only 3 nodes. I'll be setting up my master, your name node, secondary name node, job tracker on 3 independent machines. On the same nodes, we'll be having your data node and the task tracker. Because these are just software process, right? Daemons running in the background for you. They can be set up anywhere, not a problem. But only thing is, resource constraint may arise when you start processing the data. Or when you start storing the data, the resource constraint may arise. But for POCs and all, that's fine. But production, no chance. Production will have things separate. That is why, depending on the type of the cluster you are setting up, your need also changes.
But
because you have a development cluster, testing cluster, and production cluster. For both development and testing, what you said, that is absolutely out. But on the real environment, go ahead.
So when something is possible in dev and QA or testing environment, the same thing can be implemented in prod also, right? So why do you say such a thing that if your dev and QA are of same configuration, the prod also can be of same type, right?
No, in the production, what we do is we keep the actual data, right? And we expect different clients will submit their jobs, and a lot of pressure will be on your name node and your task tracker, job tracker. So we expect them to be configured on the separate high configured machines, and data node and task tracker will be on a normal hardware.
Because not really, right? If you, for example, let's say if your PMC or performance testing environment, you have to test the job with the same volume of data so that you know how it is going to actually perform when the job gets deployed into prod. So the volume of data, sometimes you will have to test with the exact volume to predict any issues that would occur in prod. So your own environments, at least your PA performance testing environment will be of same configuration as per your product. And in this case, we have a resource. My question is, we have a resource constraint where we have only 3 servers. We don't go. We're not given the luxury to actually have more servers, because the cost and everything comes into picture, right? When we talk about Hadoop, you can utilize your existing resource in a much efficient way. That's the reason why companies go with Hadoop. So now we cannot go and say, oh, to have Hadoop, you need to have 6 servers. That's something which is not favoring the philosophy of Hadoop, right?
Yeah,
so whatever hardware you have, you're going to scale and
yes. You're right. I'm not denying that one. Here, Jay. I'm not denying that one. But you see, coming to the masters, why we need, because both your name node and your job tracker are process intensive daemons. They are process intensive daemons because why they are process intensive daemons? Because every request go through that one only.
Okay.
Heartbeats and all needs to be managed by these only. Because every fixed interval of time, every node should send a heartbeat. That needs to be managed by the master only. It is the responsibility of the slave to send the heartbeat to the master, not the master knocking. So, within the activity, there is a lot of pressure on the name node and your job tracker. Of course, job tracker only when the jobs are running, not every time. But name node we will have that because it keeps track of all the services on your cluster. And
so I want to give it a small pass here. So let's say I have 3 machines, as you said. So 2 nodes I'm going to define it as master nodes, right? I'm going to call it as master name nodes. So I can say node 1 and node 2 will be name nodes.
Yeah.
Whereas the third one can be how do you call it, a slave node? Because these terminologies I'm hearing it for the first time, so that's why I'm trying to understand in my own language. So the third node, what do we do? It's a slave node. So how would you call that as a slave node?
We call that as a slave node, basically. Yes.
Okay, fine. So these two becomes
that is what we are trying to see here.
Okay.
Yeah, I mean on a normal setup, what usually we do is we take one high configured machine, and on the same machine we keep both name node and job tracker, and a normal machine where secondary name node, and all the other normal nodes with normal configuration, hardware abilities and all, we set up the slaves. Nothing but your task tracker and the data.
So let's say you made one machine as the master node. If for some reason, if it goes down, if the server dies, that means, are you saying that the whole Hadoop environment is going to be down?
Yes, that is a threat. That is a threat.
That is not, but that cannot be a threat because your high availability is something which is very important because you're processing huge volume of data. That means processing has to go continuously, and you cannot sacrifice there is no downtime. You cannot sacrifice on any downtime. So that's why the requirement is to have a high availability.
Remaining and all, remaining and all is fine. But if name node is down, then we don't have any alternative for that. But this all I'm talking in the context of my Hadoop 1 when it has been introduced. But with the advent of Zookeeper, your quorums and all, if you see, your high availability has gone to the level of 99.99%. Okay.
Okay.
Your high availability has gone to the best extent. But in order to make you to understand the aspects from the grassroots level, I am saying name node is called as a single point of failure. But engineers has overcome that one very long back. Now name node is no more single point of failure. So we have things in place in such a way the cluster is 99.99% available.
Oh, so
high availability is been achieved. But to make you to understand the aspects, now you'll be definitely asking the same question over a period of time. So that time we say, oh, now we have these things in place. That is the reason why high availability is being achieved. But interesting that you asked now itself. Maybe you might have done your basic homework. That is why you are aware that high availability and all is mandatory when it comes to the Hadoop and its ecosystem. So I am compelled to give the answer to that, but that has already been achieved. It is not that, it is no more your name node is no more a single point of failure. Mechanisms are being developed like that.
Okay.
You understand what I'm saying now at least?
Yeah, you said the high availability has been implemented, but how it is done is still very unclear, because you have only one master node. With one master node, you cannot achieve high availability for sure. So that's why I took the three servers as an example where
we will not be having one master node. We will be having its data present at multiple locations, so that your high availability is achieved. What is this master node? What is this master node? In the beginning, the master node itself used to maintain the data within it. So if the master node is down, then the data that is attached to that one is also not available. So the total cluster is not available. But now I make my name node available in terms of rendering the services only. That's it. But the actual data is being made available in the form of replications again in the background. So high availability is always been achieved.
correct. As you said, replication means you will go for a shared file system, which is being seen by both. Let's say, because my understanding is you should have two master nodes, and both these master nodes should have access to the files that it is processing, so that if one goes down, the other
No,
one
we will not be having
processing.
two master nodes. That is what the thing here. We will not be having multiple master nodes, one master node, but with multiple shared file system in the background, so that through the same window we'll be able to access all that.
But if one goes down, let's say let's say the master node goes down, somebody has to take the responsibility, right, to continue the process from the place where the master
At the
node.
very minute level, if you go to the very minute, precise, level, if that is down, definitely human intervention is needed.
Hello?
Okay.
Hello?
Yeah.
So
Hello?
I really don't get the whole picture. Can you just show from the like how this is who connected to who, how this works? Because I think without getting this, how this actually works, just saying I don't think it's gonna help, because I think if we understand this whole picture of this here, is better off. Like example, this client gonna send it to the name node gonna do this, what this is going to do based on this picture. I think it's going to be better understanding, I guess.
Marcin, is this Marcin?
Yes.
Marcin, that is what I mentioned in the last session. Please go through the document what I mentioned. Don't mistake me, because to get the details about the name node, secondary name node, job tracker, and then you have data node and the task tracker. So that I've already mentioned it. Okay. So we are trying to work with these things to understand more in detail. But Vijay, I think, maybe if you are able to hold your patience for the next 1 or 2 sessions, I think you may get more clarity. Maybe at this stage, we will have that ambiguity still in the mind, that how that is being achieved. But one thing is sure, high availability is being achieved at your Hadoop level, and that is clear. There is no second thought in it. But how it is being achieved, until and unless I discuss about Zookeeper and all, I will not be able to make you to get convinced. But to make you to understand those things, we definitely need to wait a day or two, so that we understand, oh, that is how it is being. But for sure, high availability is being achieved. Okay.
Okay, Srinivas. Thank you.
Okay. Okay. So we'll see how this, to the best extent, how this is being addressed. But to get into the subject, we are now trying to understand that these are the daemons and these are the roles. What exactly is happening? See here, job assignment to the cluster, metadata operations to get block info. Client is communicating with the name node only. Actually, you see here, client is communicating with the job tracker only here. That is the reason why I said this diagram is very, very important. But truly speaking, your data reading and writing is happening directly from the corresponding nodes only. I mean from the slave
This
nodes.
is what I'm talking about. This is what I'm talking about. If you can tell me this way, it's better. Thank you.
Yeah. So your actual data reading and writing, of course, these are all the things happens behind the scenes. We will not be able to visualize that one anytime. But to make you to understand, I am telling you, your initial request goes to the master only. What been explained by me here in both, what are the two things we have? Data storage and data processing. In data storage, we have a master. In data processing also, we have a master. Same like we have slaves in both. So every time your request goes, it goes to the master only. But master is only going to give you the information regarding that. So what your master says, when you want to process a file called foo, you actually submit your job to the job tracker. But job tracker, how it decides where the processing needs to be done, job tracker immediately communicates with the name node asking for the file called foo where the blocks are located or present. I am talking about the actual blocks, not the replicas. So the name node is going to respond saying, for this file called foo, there are 3 blocks which are present on node 1, node 5, and node 6. Then immediately the ZAR file that is being submitted to the job tracker is transported to those 3 nodes, node 1, node 5, and node 6. That is the reason why I said, friends, when it comes to your Hadoop discussion on Hadoop, I don't say it as a problem. You are learning Hadoop admin, and the other side we are learning about Hadoop developer. You see, Hadoop admin, 80% of your subject is admin and the remaining 20% is development. Same like when you go to Hadoop developer, 80-20 again, 80% you are a developer and 20% you need to be an admin. So certain developer aspects also needed. Why? Otherwise we will not be able to understand. Because you see here, how I run my job, I run my job by using this command. What is that command? One second. Hadoop ZAR, I specify where my ZAR file is located. Hadoop ZAR, say my ZAR file is located in work, then MapRed, then MR jobs, imagine I have something called mrjobs.zar. I mean mapreducejobs.zar. Okay. Then I'm going to specify my job and I'm going to specify /tmp /sandbox /sample.txt /tmp /sandbox /sample_out. Now see here, when I am using Hadoop ZAR, I am telling where my jar file is located. Within the jar file, there could be number of jobs. Which job you want to run, I am telling, that is called the job name. When the job is getting executed, from where it should read the input data, I am specifying that one. And when the job processes the data where the output should be stored, I am specifying that one. This is how I submit my MapReduce job. Now, taking this into consideration, come back to this diagram, friends. You will be able to definitely understand when the job is submitted to the job tracker, nothing but the master, the job tracker will communicate with the name node that may be present on the same node or it may be present on the different node depending on the type of the cluster you have set up. If it is a testing or a development cluster, usually all the masters we set up on one node with slightly better configuration. Maybe memory wise, CPU wise and all. And your slaves are being configured with commodity properties like, little memory and little computing power is also fine. So immediately your job tracker talks to the name node saying, I got a request to process this data. Please let me know where the data is available on the cluster. Name node knows where the data is available. Immediately it responds to the job tracker. Then the job tracker will come to, oh, I want to process a file called ABC whose blocks are present on node 1, node 5 and node 7. Then immediately this jar file is transported, whatever the jar file. Maybe your cluster has got 100 nodes, but this jar file is transported only to those 3 nodes. This jar file is transported only to those 3 nodes. Try to understand that one, friends. Is transported only to those 3 nodes, not to every node in the cluster. How come only those 3 nodes? Because the name node has already replied, the data for this input set, that is sample.txt, the data blocks are present in node 1, 5 and 7. Only to those nodes this jar file is transported. What the job tracker will do, transporting this jar file to only those 3 nodes, and this jar file is received by the task tracker present on each slave, on each node, and process the data then and there itself. That is why we call it as data locality. Of course, it is not needed to the admin, but need to understand how things are happening at the grassroots level. That is why we need to know certain basics of even execution part. Don't worry. I'm going to show you physically how a job is being submitted and processed against your cluster. Don't worry for that one. But make you to understand all these 5 daemons. See, this is important, friends. You need to first understand that that is the reason why I requested you to go through the daemons. If you might have gone through, this will be very easy for you. In a standalone mode, there will be only one machine and exactly one JVM. And that JVM is to run your MapReduce job. There will not be other daemons at all. That is why I said this mode or setup is only to experiment MR. Experiment MR jobs. The moment you develop a MapReduce job, you want to quickly test it, then you go with the standalone mode. In the pseudo cluster mode, if you see, I have one machine only, but in that machine 5 JVMs will be running. For what purpose? For all this one. That is the reason why here replication is not possible. No replication available. Why no replication available? Because there is only one data node and one task tracker, or there is only one data node. Replication is not possible. But when it comes to the fully distributed mode, there are multiple data nodes, so replication is possible here. And you are saying here, Vijay, if I am not wrong, you are saying here, with 3 machines also we can do that. Yes, you are right. With 3 machines also we can do. How? On the same name node, secondary name node and job tracker, I also can make my data node available. With 3 machines also I can set up my fully distributed mode. But
yes,
we don't do that for the reason the net load on that machine will be high, and because of the congestion, the time which it takes to process your data will become more. Instead of your task getting finished in 2 minutes, it may take 20 minutes because of the resource constraint on that. That's the only harm. Otherwise, with the 3 machines also, we'll be able to set up a fully distributed model. Are you able to understand, Vijay?
Yes, Srini, I'm able to understand. In that case, can we have the data node servers with the high configuration, and can we go with the name node and secondary name node configuration to be slightly lower than the data nodes? Because the name node is only going to distribute the work, right? All it says is, okay, you know what, this is the process, let me distribute it to the data nodes, and the process actually runs on the DN. So I believe that if we have those DNs with high configuration, and the name node and the secondary name node has lower configuration, like, let's say we give 2 CPU for the name node and 2 CPU for the secondary name node, and we can give 8 CPUs for each data node. Would that be, is that an optimal way of distributing?
8 CPUs, you mean to say one CPU for each data node? That is what you are saying?
No. 8 CPU for each data node. So let's say for 3 data nodes, I give 24 CPUs.
No, you are saying
and
reverse.
Then
you are saying reverse. Why you are saying reverse? Because name node and your job tracker needs more CPU and more memory resources, because they are more memory and processing intensive demands.
But you just now mentioned that the job tracker gives the load to the task tracker, right? All it does is, okay, identify the process and say,
you are only thinking at that level, Vijay, but you're not thinking they're only executing, but the monitoring, coordination, heartbeats, everything being taken care by the master only.
Yeah, but this all comes into network traffic and all other factors, right?
True.
See, the heavy lifting is done by the data node, right? Because that's where the data is getting processed. So the heavy lifting is generally, my understanding, you can correct me, absolutely correct me, and also, I mostly welcome that. But I assume that the heavy lifting is done by the data nodes, because that's where the data is sitting.
If the cluster is if the cluster is a limited cluster with 3 or 5 or 7 nodes of that range, that is fine. But imagine a cluster of 50 nodes. Okay, now you tell me which needs more resources.
Now it is a different ball game. Now, as you said, because the data nodes are more, so there is a lot of coordinated effort that's required. So I totally agree.
That is where you got the point now. Yes. But thing is, I will not keep these things in the mind. I mean, like what you said before, based on that, I decide that name node and secondary name node and job tracker will have less configuration, because when I am going to scale up, you know very well, Hadoop cluster is linearly scalable. As and when your need increases, you keep adding the nodes.
I mean the data nodes.
Yeah, only data nodes. You are absolutely right. Only data nodes. So you keep on adding the data nodes. You get the chance to replace your name node, secondary name node, and the job tracker, Vijay.
No, we don't do that.
That is the reason why we will have some certain metrics, not precise metrics that, oh, my cluster maximum is going to be 80 nodes. We will not keep that thing in the mind. But we'll have a tentative figure to what extent we take this in the near future. Keeping those metrics into consideration, we plan the name node, secondary name node, and the job tracker in the beginning itself. Okay. That is the reason why the concept of high configuration comes into picture. But if you ask me, for my current need exactly and precisely, you ask me to set up the resources, then yes, you are compared to the name node and your job tracker, your data node may demand more resources. But over a period of time, when you keep adding the data nodes, then the reverse is going to be applicable. So I will not keep these small metrics into consideration when I am setting up my cluster. At least the production cluster I am saying. Development cluster, not a problem. It's only to experiment, quickly experiment whatever the task that you are implementing so that you can evaluate where they are and how they are going to be meaningful. That's fine. But when it comes to production cluster, I will not take that chance. But initially I go with less configuration. As and when the need arises, then I think about the changes. Now, I keep in the mind 60 to 80 node, my cluster needs to grow, probably in the next 1.5 year span. Based on that, I make sure that sufficient resources are available with my name node and with my job tracker and secondary name.
Okay. One last question. The name node and the secondary name node, if I have to do a sizing, because that's what you do, right? As an admin, you have to size your servers and then you make the recommendations, right? So if you have to size your servers or the name node, SCN node, what is the basic or what are the things that you will consider so that you can come up with a number that is approximate or that can handle that particular volume of data?
Yes. We have the metrics actually, memory sizing. See here. Look at this one, Vijay. That is what you are looking at, right? Even in the past, you are looking at this one only.
Exactly, yes.
Look at this.
Something like that,
right?
where, is there a template or something that you have where you key in
not exactly
details and
template,
automatically...
Okay. Yes. I mean, based on this one, you can see. The amount of memory required for the master node depends on the number of file system objects. Are you able to understand this one, Vijay?
Exactly. I mean, this is all pretty much looks like, how much volume of data you process. Let's say if the organization is processing 2 terabyte of data, so that's where you start your
No, we don't see.
Right?
No. You are mistaken, Vijay. We don't see that way.
Okay.
2 terabytes of data, 20 terabytes of data, or 200 terabytes of data. We don't see in that way. We see the amount of memory. I'm talking about the primary memory needed for your masters. So the amount of memory required for the master nodes depends on the number of file system objects. What do you mean by file system objects? That includes your files and block replicas to be created and tracked by the name node. So 64 GB of RAM supports exactly, I mean, not the precise number, but approximately 100 million files.
But if the file size is big, how will this number
not file size here? Not file size here. Observe, not file size here. 64 GB of RAM supports approximately 100 million files. Each file will have block, and each block will have replicated blocks also. Those also put together, we call it as a file system objects. You got the point?
Yeah, to some extent. I think I have to digest this and get back to you.
No. What is the responsibility of the name node? It is to everyone, friends.
Get the request.
I'm not specifically, as Vijay has asked the question, I'm addressing that one. It is to everyone. Machine. You need to understand this is to everyone, not specifically to one person in this session. Yeah, what is the responsibility of the name node?
It gets the request.
Yeah, name node tracks the complete details about, because name node maintains a file system, which we have discussed in the last session. What we mean by file system, that also we discussed. Name node maintains the file system image. Name node maintains the file system image. Okay. As part of the file system image, what will be there? What is the name of the file? To this file, how many blocks are present? Where the replicated blocks are present? That all is what we call it to be file system image. Right? Now, The metrics what they are giving you here for your sizing and all, your 64 GB of RAM in your name node will approximately support 100 million files. Now you will have a figure in the mind, right? How many files, not the data volume. Data volume is different. That is actually in terms of your storage. I'm not talking about that. That is why, friends, you need to understand here. I don't know whether you've gone through this statement anytime while reading the documents or not. Hadoop is basically meant for large files in terms of the size which are less in number rather than what is that? Small files more in number. This is a straightaway statement. Now you can understand why this statement is being given. Hadoop is basically meant for large files. A file of or even terabytes, a file of terabytes. I'm not talking about the hard disk capacity. I'm saying the file of terabytes. A file of 10 TB, 20 TB is quite natural at your Hadoop level. Hadoop is basically meant for large files which are less in number compared to the small files which are more in number. The reason behind, every file that you store at your Hadoop level, what is needed? What is needed? Its meta information needs to be preserved. What do you mean by meta information? What is the file name? How many blocks it has got? And where those blocks are present and where their replicas are present. So these what we call it to be the storage details. So when I am trying to access my storage details, I should not face any challenge. That is why a 64 GB of RAM, because your file system image is always present in the, if it is present on the disk, then it is very expensive to retrieve the data at times when it is needed. That is why we make sure that this file system image is always available from within your machine itself, in your name node itself. So 64 GB of RAM supports approximately 100 million files. And what CPU is needed for that one? 16 or even 24 CPU cores to handle the traffic. Providing?
Srinivas.
Yes.
Sorry, okay. I'll let you finish and then I'll ask a question.
Yeah, go ahead.
Okay. Two questions. One, I think Hadoop software is responsible in storing the data and retrieving data. Is that understanding correct?
Yeah.
Okay. Because, and processing the file and processing that data and generating a desired result, that is happening outside the Hadoop world. Is that right?
Yeah.
Okay. What kind of tools generally will do that? Processing the data.
You can have a MapReduce as one layer, Spark as another layer. On the top of Spark, we have machine learning libraries. You have Spark SQL libraries with which you process data using your in-memory. A lot of libraries are there. A lot of frameworks are there. Okay.
But MapReduce functionality is to store and retrieve, right? That's processing the data is. I'm talking in terms of the ETL world where you extract the data and then you transform and then load, right? So I'm talking in terms of the transformation. So who will do the transformation? Say you extracted the data, which is being taken care of by the MapReduce, or Hadoop software will take care of fetching you that big, huge volume of data and give it to you. Now we have to process, and I mean by process transformation, you have to transform the data to whatever whatever result you
No,
want.
usually we do that one using your MapReduce. Sometimes we do that using your pig or hive. We transform that into the way you want, and then you try to perform your analytics on the top of that.
Okay.
So there is no thumb rule there. There is no thumb rule.
Fantastic.
Come to the Hadoop processing. There is no thumb rule that you must do only with MapReduce here, you must do only with the pig or hive here. No, there is no thumb rule. It all depends upon the architect and the comfort he enjoys with the team. Based on that, he decides how the data needs to be processed. If you take the scenario, at Facebook, they will never use MapReduce directly. In the place, they always use Hive. To take Yahoo, they never use MapReduce directly, but in the place they use pig, because these are the components which actually developed by them. And later they contributed to Apache.
Okay, right. Thanks.
So there is no thumb rule there. But truly speaking, the only framework that Hadoop, Apache has provided to you is your MapReduce framework, with which you can process data quickly because of the massive parallelism in the background. Massive parallelism I talk very in detail. Don't worry for that. But I want you to basically understand the role and the responsibility of these daemons. Name node, secondary name node, and your data node, job tracker and task tracker. These 5 daemons, their roles and responsibilities, if you understand, then it will be easy for us to configure either on one machine or multiple machines and make sure that these services are accessible for your usage. And as you specifically asked, I have shown you this one, but that's fine. These metrics are here and there, not exactly or precisely, because it depends upon. You may ask me one thing. 64 GB of RAM supports about 100 million files, but I can say 64 GB of RAM supports more than 100 million files, provided if the files are moderate size. Huge in number, then it will be tough, because each file throws a lot of metadata. Throws a lot of metadata, I mean? What do you mean throws a lot of metadata? What is the file name? Where it is being stored? What blocks are associated? Where the replica blocks are there? This entire story needs to be maintained by your name node only. Not only that one, every 3 seconds or 5 seconds, depending on the setup you made, every slave is going to send a heartbeat saying, yes, I am alive, I am alive. Based on that only, your name node is going to decide whether this node can be considered for further storage or not, will be decided based on that only. Okay, so that is the reason why I said here, these metrics I can give, that's not a problem. These metrics I can give, standard metrics these are, but we at the work level, maybe these metrics are going to slightly offer but not abnormal. What you need. So name nodes and their clients are very chatty. We therefore recommend providing 16 or even 24 CPU cores to handle the messaging traffic for the master nodes. They are telling what memory is needed, what processor is needed, and what network is needed. Providing multiple network ports and 10 GB bandwidth to the switch is also acceptable for the above configurations what we mentioned. I mean, memory sizing and process will be taken care. The network is going to be taken care of those details. Make sense, Vijay?
Yes, sir, very much.
So somewhat better. I totally agree with you. It's definitely not going to be 100%. There will be ambiguity still, but we need to wait for another 1 or 2 sessions to actually understand your high availability aspects and all those things.
Thank you, Srinivas. So far, very clear.
Yeah. So, what are the 3 modes in which your Hadoop is been set up? Your standalone mode, which we don't see and which we don't work with it. But if you are interested, please follow the instructions from hadoop.apache.org and set up on your CentOS box. Download the library, set up your home, and make your thing accessible, because it is only to quickly experiment your MapReduce jobs. Anyhow, that is not our consideration. That is the reason why I said standalone will not be doing it. But even if you need to do, we don't have anything to do there except downloading the library, setting up the home, Hadoop home and Java home, so that you can quickly run your MapReduce job as a developer. It's basically for the developer front, not for the admin front. But pseudo cluster, we don't have much thing to do. Setup wise, we don't have much thing to do. But learning curve is more in the pseudo cluster. With the pseudo cluster only, we will be learning all the aspects of Hadoop administration. But in a fully distributed mode, we will see the actuals of how you add the nodes to your existing cluster, how you deploy the client configuration, how you make those as an integral part of the cluster. All those things you'll be seeing as part of your fully distributed mode. As of today, like how, Vijay, I can say this one. As of today, like how in SAP, we have a certain metrics being fixed. They are technically called as best practices. Like that in Hadoop, there is no best practice document and all that is formulated, because by the time I'm about to formulate certain best practices and all, I'm getting new components into the ecosystem. So I'm behind those. I'm behind those. I'm not able to streamline the aspects of, what is the best practices. You know very well that MapReduce was very peak. I mean, job tracker concept and all. Then immediately your yarn came into picture. With that, MapReduce became a small part of the yarn, but not everything. And now, all together, we are seeing a new thing called Spark, which is in-memory computing, which is a great buzzword in the industry now. So maybe in the next 2 years or so, we may be seeing different things. By the time the technology is getting matured and I'm formulating the best practice and all, we have the advanced components coming into market, and I'm not able to do that one. You understand what I'm trying to share?
Yeah, Srini, what I meant by that question is, let's say in a typical data processing world, or the BI world, I'll call it as more specific. We need to have some starting point, and that starting point will be based on the volume of data. Each organization will have different volume, and they know exactly how much data they have. Like, some will have 2 terabytes, some will have 10 terabytes. It really depends on the organization. So we take this as a starting point, and based on the experiences, we will come up with the configuration saying, okay, my prod has to be, this is the sizing I need to do for my prod, this is the sizing I want to do for the QA and other environments. But the starting point would be the volume of data, and from there we come up with ballpark numbers of CPU, memory, and everything. And after that we monitor the services, and then after that, based on the performance, we either increase the resources or that's where we do the optimization. But at least we know where to start, and then at least we know where to start and how to move ahead. In the Hadoop world, I'm exactly trying to find out that starting point, so that
No. That is where I say, Vijay, I really appreciate your keen observation towards things. I really appreciate. We will not be able to come to that conclusion, because if you are sure about your needs, the very immediate need, we can. I tell you, even we have set up the cluster here, a 6-node cluster on the same machine. Let me be very honest in that. I don't claim that we have this, that, and all. We have I think it is 12, because 6 cores, 6 cores in each, 2 process. Yeah, 12 cores we have. 12 cores we have, and 48 GB. No, 64 GB. Sorry, 64 GB RAM, right? And we have set up around 6 VMs. Okay, 6 VMs, and it is taking automatically. And we have another 3 VMs for our other activity. So altogether we have 9 VMs. We have altogether 9 VMs running on the same machine, 6 dedicated for my Hadoop cluster and 3 for my other activity. And I have given 8 GB to my masters, and for Clouder Manager I have done a separate setup. For that sake also I have given 8 GB, and remaining 6 GB like that I have given. Getting the point?
Yes.
I have set up that one and we are working with it. There is no metric, and if you ask me technically how the cluster needs to be set up, then I can only say, basing on these kind of metrics, you will decide how much memory and CPU needed.
Okay. So the number of files that you are processing is limited by the memory, because now you have 6 gigabytes. So only equivalent to that many number of files you can have.
Yes,
right?
yes, because it is all based on the number of files in terms of your memory sizing to your master. Which master? Memory sizing to your name node. See here, sizing and all depends upon the master that you are working on. It is not the same common sizing to everyone. Sizing to my name node is different, and same name node sizing for applicable to your secondary name node also. But for your job tracker, the same name, same sizing is not applicable.
Okay.
Right? So we talk about, I give you these metrics. So these are the metrics that are being followed. And again, these are out of the various observations and all. Hortonworks, Clouder and all, they recommend that these are the things. But it's not that we need to definitely follow those things. Out of their experience, their expertise, and the interactions with the client, setups and all what they have done, their experiences, they formulated that these are the metrics. That is where I said the point before. By the time I'm about to formulate certain standards and all in the Hadoop ecosystem confining to certain components, the advanced components are coming into picture where these are being neglected.
Okay. One last thing, I think it's very related to the interview as well, from the real-time perspective. Do you know any clients, actual configuration of any of those clients? Like there are so many clients outside who are using Hadoop, right? So do you know what is the configuration that they are actually running on?
Yeah, those use cases I have. I have those use cases. Different clients. What is the Hadoop cluster size, and what they are using. Whoever has published, those details are there with me. I mean, not every client, but at least a few documents I have with me that this client having a 30-node cluster of this capacity, and this is the volume of the data they are handling it. So those metrics are there. Those details are there.
That will be very handy because, for example, JCPenney might have huge volume because they are into retail, and Facebook might have a different volume of data processing. But once we know the configuration, to set up a cluster for an insurance company, it might be a different number, but that will definitely help us to see, okay, what kind of cluster they need, because the volume is definitely less when compared to a retail industry. So those things will really help us to plan.
Definitely. Those metrics, I mean, those documents also I will be sharing with you so that you get the clarity on them. For sure.
Thanks, Srini.
Yeah. That's wonderful, friends. That's wonderful. So what I advise you now to do is, I think with this you have understood, and the diagram what I've shown you here, same diagram we repeatedly come across. Same diagram. Maybe with a different set of components and all, but the diagram is going to be the same. We'll be having. So at least now with this you understand what what are the basics that are needed from your end to understand the concepts thoroughly. These are all the theoretical aspects. If something is practical, I might have taken care from my end. But these being the theoretical aspects, I advise you to go through the documentation provided by Apache. The documentation provided by Apache. For this sake, please don't take everything into consideration. Hadoop rack awareness. Before studying in detail about rack awareness, I advise you to go through this paragraph. That's it. Hadoop startup, how it is been done. Of course, we don't do all these things in the recent. This is all from the Apache. When you start your pseudo cluster, all the services are up and running for you. You need not start anything. But as an admin, if you need to manage these services, how they need to be, you have here. How you start a daemon, how you manage that one, and what is the safe mode, how you bring your name node out of the safe mode. If it is not leaving voluntarily, how you can make that to come out of the safe mode. Those things you can go through this document so that you will be able to understand. And you get acquaintance with this, with the technical terms. The more you use the technical terms in the interviews, the better chances that your skill set being identified. Because they understand technical terms can be used by the people who worked in the real environment, who got habituated to that one. That makes the interviewer to feel confident, yes, you are capable. So please go through these things, friends, whatever we discussed today. And I say you need to go through these things with the intention that, you know, at your comfort you'll be going through so that your sessions will not be impacted. And still you have questions, please feel free to ask in the session, probably during the session or at the end of the session, so that you'll be clear with many of the aspects. Mahsin, you asked certain things, yeah. Now you can raise whatever the questions that you have in the mind. So Ganesh, Mani, Sunil Reddy, you have any questions, please feel free to ask friends. Have any questions, friends, to me for today?
No, Srinivas.
If no questions, we end up at this level. We'll catch up again in the next session, friends. If no questions to you at this level, we end up at this level and I catch up in the next session. Have a great time ahead, friends. Thank you for joining with us today.
Thanks, Srinivas.
Yeah, wonderful, Sunil.